Welcome back everybody to linuxacademy.com. My name is Terry, and in today's course we continue our preparation for the Linux Foundation Certified System Administration exam. Specifically, what we're going to be talking about here is how to install and configure SSL with Apache. Now we're going to take two tracks to this. We're going to talk about SSL certificates and certificate generation in this video. And in a subsequent video, we're going to talk about how to add that to a vhost configuration so that we can answer and listen on port 443 for SSL traffic using the certificates that we create in this video. So we're going to create a self-signed certificate to use with Apache. Now there are two kinds of certificates in general. There's all kinds of sub-certificates with different encryption types and key sizes, but there are two kinds of certificates. There's one, a self-signed certificate, which is what we're going to be doing. And a certificate in general is something that is provided that encrypts the traffic between the endpoint, which is the server, and the originating point, which is me from my web browser, that secures the traffic between them. That certificate that uses keys to encrypt that traffic is signed as a legitimate certificate guaranteeing some level of authenticity and encryption. Now, a self-signed certificate means that the authority signing the certificate as a valid certificate is just me. I'm generating a ticket on my own server, and I'm installing it. The traffic is encrypted, but it can only be trusted as much as you can trust the endpoint to install a certificate that isn't going to compromise your traffic. A self-signed certificate is free, and it can be installed, and it does indeed encrypt your traffic. So if you, for example, are using your own server that you're going to access remotely, and you want the traffic encrypted, there's nothing wrong with installing a self-signed certificate and then accessing it this way. What you're going to see in a browser, however, is you're going to see anything from a warning to a redirection that says, hey, this site is not set up as a fully signed, authenticated site. Since you did it, you can go ahead and obviously accept that risk. That's what we're going to do here. So we're going to generate the keys and then eventually the certificate that we'll be able to use. However, if we're using a certificate that we want to purchase from VeriSign, for example, which is a common certificate assigning authority, then not only it costs anywhere from a couple of $100s to a couple of $1,000, but then that self-signed certificate becomes a full certificate that will show green in your browser and verifies encryption by a third party all the way from client to server. Again, the process for installing and using certificates, whether they're self-signed or whether they're authenticated with a signing authority, are exactly the same. And I'll differentiate what things apply to self-signing versus what you would do if you're purchasing a ticket. So if you're on an Ubuntu system, SSL is already installed and you just have to execute a2enmod to enable the module SSL. For CentOS, we have to install the mod SSL module. So we would need to do a yum install mod SSL. And this will install what we need. And then, of course, we're going to have to generate the certificates and then later enable them in Apache. So let's go ahead and finish this install. And then what we're going to do is, although this isn't necessary because you can write a key and the certificate wherever you would like, we're going to create an actual directory that we can refer to inside of our etc httpd directory. So let's do etc http. And within here, let's make a directory called SSL certs. Within that directory, now we're going to use OpenSSL to generate a key and then use that key to output a certificate. Now, I'll try to explain what we're doing one item at a time, and because it's quite a long command in order to generate a valid self-signed certificate. So what we want to do is we want to generate it, and we'll talk about each of the options as we go through. So we're going to start out with OpenSSL, which is the command that we need to generate the keys for signing the self-signed certificate itself. So let's talk about REQ. So REQ-X509 is what we'll start with. and it indicates we're creating what's called an X509 certificate. And an X509 certificate is the most common certificate that you'll see. There are other kinds of certificates, particularly if you're going to be generating something that's only going to be used for certain types of traffic. There are other certificate numbers that you may want to generate, but in this case, the standard is X509. We're going to indicate nodes, which means it's actually no DES, which means don't encrypt the key. We don't need to encrypt the key. It's going to remain here. We want to expire this certificate in 365 days or a year. So we're expiring our own certificate in a year. Now, we could put another value in here. If we wanted this to be a 5-year certificate, we could, but you'll generally see most self-signed certificates that will expire in a year, and most certificates you buy from an authority will last for 2 years generally. We're going to do a dash new key, and this is where we're going to tell the system how to generate an RSA, which is the standard encryption model for certificates, and we're going to generate a 2048-bit key. So we're generating a 2048-bit RSA key, which would take, depending on the system that you have, quite a bit of time to intercept and then crack in order to listen in on the traffic that's encrypted with that key. We're going to be creating the key out, and we're going to tell it to put it in the directory that we just created, httpd SSL-certs, and then we're going to call it apache.key. You can name it whatever you want as long as you remember what you name it. Then we're going to take that key and we're going to output the path for the certificate, which is etc httpd SSL, and we're going to call it apache.crt for certificate. Now, it's going to ask us some information to fill out about your certificate, and this is important, especially if you're generating just the key that you're going to pass on to a third party. You're going to want to put in your country name, your state or province. In this case, we'll just put in New York. We'll say we're in New York. The organization name is Info Limited. The unit name is Information Technology. All this is optional name. This is optional information. Here, the common name is your name or your server's host name. So in this case, we can just say Linux Academy. The email address would be like admin@domain.com, and it will generate at that point a key. So if we now go over to our, well, we're already actually in that directory. Let's clear this so that it's clearer. We look and we see we have both a key and a .certificate file. So if we cat the Apache key out, you'll see that this information that you have is generally what you would then copy and paste either into a utility for a third-party certificate authority to generate your certificate from, or in our case, we actually generated the certificate from that key that we decided to self-sign. So now that we've got a certificate and a key in a known location signed by us, then we need to go in and configure Apache and our virtual host so that we will listen on port 443, and that traffic is then secured with that key and that certificate so that everything between my browser and the server is then encrypted. For generating SSL certificates for use in Apache, self-signed, that's all there is to it. My name is Terry for Linux Academy.